This is Lecture 41 in the FOA series of lectures on fiber optics. In this lecture, we're going to talk about prefabricated fiber optic cabling systems. What we call prefab are also called pre-terminated or plug-and-play cabling systems. They're essentially factory-made cabling systems completely built in a factory and shipped to the job site for installation. In this lecture, we're going to talk about the basic issues of using prefab systems: design, purchasing, installation, testing, and maintenance. Prefab cabling is generally used where it is considered more expeditious to install a cabling system that is factory made rather than terminating cables in the field. They're widely used for parallel optics for 40 and 100 gig Ethernet and in data centers, and special applications where termination is difficult, like fiber to the antenna or fiber to the home or tactical cables. Prefab cabling is not a new idea. Here is an example of a factory-made cable assembly terminated in the factory with a custom pull boot around 1990, which was used in premises cabling to install cables without having to field terminate. Here is an example of a present-day prefab cable. This one is designed for fiber to the antenna, connecting the antennas on the top of cell phone towers to baseband units. It has 6 LC fiber connections plus 3 copper wires for powering the antennas inside an armored jacket. Many prefab cabling systems use what we call an MPO connector, multi-position optical connector, which is a connector that has anywhere from 12 to 72 fibers in a single connector. This connector's been around for 15 years. It's strictly factory terminated, although there are options to field terminate with pre-polished splice connectors or fusion splicing on pigtails. In today's market, you'll see MPO to MPO cables, breakout cables, and modules, which are terminated in the MPO on one side and single fiber connectors on the other. The MPO connectors are plastic molded rectangular ferrules aligned by steel pins and holes. There are connectors with pins, which are sometimes called male connectors, and connectors with holes or no pins, which are female connectors. There's also keying on each connector and in the mating adapter to make sure the fibers are aligned and connected 1 to 1, 2 to 2, etc. correctly. MPO connectors basically come in 4 varieties: pins, no pins, and key up or key down. This is to align all of the fibers in the connector correctly, but makes having the right cables for patch cords and testing very complicated. One connector solves this problem. The Pan MPO by Panduit allows selecting both pins, no pins, and keying in the connector itself, so one connector can be set up for any of the 4 varieties. There's actually even more variations on MPOs. Typically, patch cords have no pins, and receptacles or install cables have pins. You can have flat ferrules for multi-mode or angle ferrules for single mode to reduce reflectance. You can have various color code schemes, and between that and the keyed connectors, and whether you have breakout cables or modules used to convert single fiber connectors, There are over 20 pages of options of how these connectors and cables can be made in industry standards. One type of prefab cabling system is just designed to replace a standard single fiber connector cable plant. In doing so, it will usually have MPO to MPO cables in the backbone and modules on either end that break out to the single fiber connector needed, usually LCs or SCs. These cable plants will support any kind of network based on traditional fiber optic cables. The second type of prefab cabling system is designed to use with 40 and 100 gig multi-mode parallel optics. In this case, the actual transceiver has a port for a multi-fiber connector, typically a 12-fiber connector for 40 gig and a 24-fiber connector for 100 gig. So these kinds of systems will be built completely out of MPO connectors. The most important part of a project for a prefab cabling system is the design. It's the most important step because you must get the spec right the first time. You must get the length, the type of fiber and cable, the connectors and polarity, the performance specs, and the documentation all perfectly set up before you order the cable plant, or it may not work. So let's look at each of these in turn. Let's start with the length. You want the cable plant to be long enough, but not too long. If it's short, you'll have to put in patch cords to make it long enough, and that may lead to more loss than your system can contend with. If it's too long, you've got lots of extra cable to store, which can be very difficult. So you have to know exactly where the cables will go through all your pathways and spaces. You have to remember where it has to go up and down walls, because that adds a lot of length, and where it has to go around obstacles, because that can add lengths too. You need to know locations for your storage loops, and you need to do a personal inspection of every square inch of that routing for the cable to make sure you don't miss anything. You've got to choose the right kind of fiber and cable. If it's multi-mode, it'll probably be OM3 or OM4, and for single mode, OS1 or OS2. You may want to specify bend and sensitive fiber so you can have no worries about putting stress on the cable with bends as you install it. The cable designs has to specify the number of fibers, whether it's ribbon or distribution type cable, and what UL ratings are needed for the cable depending on where it's going to be run inside a building. It is absolutely mandatory to design the cable plant with the connectors and the polarity 100% spec'd out. As we said, in the TIA standard 568, there are 21 pages of diagrams and notes on how these multi-fiber array connector cabling systems can be built. There's way too many ways to go wrong, so make sure that you understand it, your vendor understands it, and you get it right and in the documentation so you can get it installed properly. And if you ever have to replace a cable or add patch cords, you know what kinds to use. You need to specify the performance of the cable plant. You need to do a loss budget for the cabling to ensure it will meet your needs. MPO connectors have higher loss, generally speaking, than single fiber connectors. so you don't have the option of using lots of interconnects. You've got to do a loss budget, check it against the systems you plan on running on it, add all that to the documentation. And by the way, make sure that you and your vendor agree on how you're going to test the performance of the cable plant, because that is very important to make sure that you know what you're going to get and can test it and prove it when it's delivered on site. The documentation on your design and on the cable plant as built must be complete. You need to record all test data. The manufacturer should have all their test data included in the documentation. You need to keep several copies of the documentation in safe places, because if you do moves, adds, and changes, or have to do any modifications or restoration to the cable plant in the future, the documentation will be a lifesaver. When you're purchasing a prefab cabling system, the first thing you want to know is, does your vendor have experience building these cable systems? Do they or their subcontractors have experience with MPO connectors? How do they do their testing? And what is the warranty? Because you want to make sure you know what the warranty is of the cable plant, because you'll have to test it before and after installation and agree with your vendor if there's problems. Don't forget, by the way, that you not only need the cable plant, you need the appropriate hardware. Patch panels, cable trays, spools for service loops from excess length, and so forth. It sounds like installing a prefab system should be easy, right? No splicing, no termination. But you've got to test it to make sure that as it's delivered to your facility, that it meets its spec and it has not been damaged in transit. You need to make sure that all the connectors are cleaned and protected, that during the installation you don't kink or stress the cables, and that every time you do a connection, you clean and inspect the connector, because the MPO connectors have large ferrules and are particularly susceptible to contamination and dirt. And don't think that just anybody can install a prefab cabling system. You're installing a fiber optic cable with connectors on the ends that requires proper handling, and that should be done by trained personnel. Installation personnel should know how to handle the cable carefully. If they're going to pull cable, they need to know how the manufacturer intended it to be pulled. Are there pull loops on the cables, for example? The ends of the cable must be precisely located, because you can't go back and pull them into position after you install it. You have to plan for locations of service loops. And before you connect any of these connectors, you have to clean them. Planning for the installation is more complex than you think, because the ends of the cables must be placed precisely. You can't cut them off to the right length. As part of your planning process, locate where you're going to store your excess cable and how you're going to do it, so you'll know where to leave excess length and how to spool it up, get it out of the way, and protect it. Just because the terminations were done somewhere in a factory doesn't mean you don't have to test the cabling system. You have to visually inspect it to make sure the connectors have not been damaged and they're clean. You need to clean them and inspect again to make sure they're cleaned properly. You have to know how to set up the cable plant so the polarity is correct, so you get connections from transmitters to receivers like you're supposed to. If you do OTDR testing, you have to agree with the manufacturer on how it was done. If the cabling has SC or LC connectors, the entire cable plant's easy to test. But MPOs are much more difficult to test. So much we're doing an entire video for YouTube just on how to test MPO connectors. Look for that on our YouTube site. MPO connectors have big, flat ferrules, and they're very sensitive to dirt and contamination. There's lots of area to get contaminated and get dirt on it, and dirt on one side of the connector may affect the loss of fibers on the other side. So you have to inspect it, clean it, and do it again until it's perfect. You'll need special tools, special microscopes to inspect it, and special tools to clean it. Make sure you know what these are and have them on site when you do your installation. I don't care what anybody else tells you, there's only one thing you need to know about maintaining a fiber optic cable plant. Put everything behind locked panels and never allow access to the cable plant except by trained personnel. Fiber does not require maintenance. Connect up the system and don't touch it unless you have to, which is generally only going to happen if somebody comes in and damages it. We're the Fiber Optic Association, the international, non-profit, professional society of fiber optics. We're a major source of technical information on fiber optics. For example, there's 100 videos here on our YouTube channel, 1,000 pages in our FOA online guide, and we have schools around the world who train and certify technicians in fiber optics. More than 50,000 of them as of early 2015.